This is an example problem for Physics 1000, Auburn University, summer 2013. So we've done this series of videos over series and parallel circuits and finding equivalent resistances and voltage drops and all of this good stuff. And so I want to put all that together and show you a little bit more complicated problem that's going to look more like your homework and more like what you're going to find on your exam. So I'm going to skip a few steps here, because I want to answer a really specific issue that we had come up in class. So the question I'm going to ask on this problem is, what is the current flowing across R2? Remember, what we know is that there's going to be some sort of current flowing in this circuit, and then when it gets to this junction, it's going to split in two. And part of it's going to flow this way through R2, and part of it's going to flow this way through R3. And then after it passes those, it's going to come back together here and at this junction and continue flowing this way. And so what we know from our discussions is that if you measured the current here and you measured the current here, you would absolutely find the same current. But inside this loop, it's a little different. This is getting really convoluted, so I'll clean it up. Inside the loop, you'll find a different current, generally in R2 and R3, because the current splits. So we're going to figure out exactly how it does that. So the first step we need to do is find out what sort of current we have. If you want to find the current across R2 here, you need to figure out what current is coming in that's going to split up. So to do that, just like we generally start any of these problems, we're going to simplify this circuit. And the first step to do that, hopefully you know by now, is to find an equivalent resistance for this loop. In other words, I'm going to replace this loop with a single resistor that won't change anything else about the circuit. So let's do that. I've gone ahead and drawn the circuit a little more simply, and here I've put in an R5, which is the equivalent resistance of that parallel loop. So now we just apply our equivalent resistance formula for parallel circuits, and I get 1 over R2 plus 1 over R3, which were the resistors inside that loop. If I put in numbers, I'm going to get 1 over 2 ohms plus, is that right? Yes. Nope. No, it's not. Let me erase that. I'm going to put in numbers, sorry. 1 over 3 ohms plus 1 over 6 ohms. If you do the math there, you're going to get 1 over 2 ohms. And I'm not done, remember. I now have to flip it because I've got a 1 over R5 here. 1 over my equivalent resistance. So to find R5, I've got to take the inverse of both sides, which is going to mean that R5 equals 2 ohms. And now I'm in good shape. I've got a series circuit, and I can add up these resistances and I can find the current, and I think at this point you all know how to do that. So I'm going to skip those steps and just tell you that I've already calculated the current to be 3/2 amps. So when I say the current, that means if you checked the circuit here, there's 3/2 of an amp flowing. This is your basic I. And if you check the current here, there's 3/2 of an amp flowing. And there's 3/2 of an amp flowing across this R5. But remember, in reality, R5 is a parallel loop. We've drawn it this way to make it simpler. But if we're going to find the current that's flowing in just one of the resistors here, because remember there's actually two, we've got to take a few steps backwards, armed with the new knowledge of what I is, and see if we can figure out what that current is. So I'm going to go back to my first page and write down I in a proper color. I equals 3/2 amps. If you're confused about how I got the current there, that's covered in some previous videos, so I encourage you to go watch those if you can't get that for yourself. But now I'm in good shape. So now I've got a current flowing. I need to figure out what the current is in R2. So what do I know? I know that this loop is a parallel circuit, which means the voltage that I'm going to find across R2 is the same as the voltage I'm going to find across R3. Now, how do I find what that voltage is? Well, the answer is I've got to check out what the potential difference is between these 2 points. And if you remember, all that is equal to is the voltage drop across that loop. And if that confuses you, just remember that anytime you go across a resistor like here, you're going to find a voltage drop. Now inside this loop, you're going to find the same voltage across each resistor. But outside the loop, you're going to find a voltage drop. How do we figure out what that is? Well, first I'm going to go back to my simplified form, and I can find it really easily here. So I simplified it to find the current that's flowing into the loop. Now I'm going to simplify it again to find the voltage drop across that resistor. And that's just using Ohm's law. V equals IR, which in this case, I should subscript that with R5. The voltage drop across that loop is going to be 3/2 of an amp times 2 ohms. And notice I get 3 volts. So I started out over here with 9 volts, and the voltage is going to drop across R1, but I don't really care about that. All I care about is how much it drops across R5, because potential difference is just that. It's a difference. So whether or not I started out with 9 volts and ended up with 6 volts, or started out with 6 volts and ended up with 3 volts, it doesn't matter. I have a difference of 3 volts, and that's what I'm going to use to find the current in that loop. So I'm going to go to my next page where I've just drawn the loop. So here's what I know. I know that coming in, I've got a current of 3/2 amps. I know that going out, I've got a current of 3/2 amps. And I know that across each of these resistors, if I measured the potential difference here, I've got a voltage of 3 volts. Remember, the whole circuit has a potential difference of 9 volts, but I've calculated a voltage drop across this guy of 3 volts. So now to find the current, it's really easy. I just apply Ohm's law again. V across R2 is equal to the current running across R2 times the resistance of R2, which is just R2. I can solve this for the current. I'll leave off the subscripts because I think you can see what they are. V over R. So I've got 3 volts over, what is R2? I'm sorry. 3 ohms. Easy. So I've got a current here of 1 amp. So we perform the same checks we did in the earlier videos when we were looking at this. Let's ask ourselves, is this current, 1 amp, less than the current that's flowing in? And in fact it is. We've got 1.5 amps or 3/2 amps coming in. So we've got 1 amp flowing across R2. Now if I were to ask you what the current is flowing across R3, you could probably answer that pretty quickly. We don't even have to apply Ohm's law. We certainly could, and we get an answer. But now you know that if I have a current flowing in of 3/2 amps, and I find a current here of 1 amp, I better sure find 1/2 amp up here. So 1/2 amp is flowing across R3. That's not what the question asked. The question asked what was flowing across R2, and we calculated it as 1 amp. But that means, because current is not going to disappear anywhere, that I have 1/2 amp flowing across R3. Hopefully this clears up some questions, and email me if you have any more.